This is the review, the bonus work for Algebra 1, Chapter 1A, that's sections 1.1 through 1.4. And the review is not necessarily quite in the order of the sections, but it does cover them. So let's start on page 27, which is actually the section where we talk about the distributive property and combining like terms. So we have 5z squared plus 3z plus 8z squared. So a reminder as far as combining like terms, you have to have the same variable pattern, and what that means is they have to have the same variable and they have to have the same exponent. So that means these two are like terms because they both have a z and the z is squared in both. So we had 5z squareds plus 8 more z squareds for a total of 13z squared. Now this has no like terms. It's a z to the first power, and it's the only term in that expression that's z to the first power. So we just rewrite it just as it is, because it doesn't get changed or combined with anything else. Okay, now 33, we have 2 minus 4n times 17. So this is just requiring us to do the distributive property, because remember, the distributive property is used whether the number or term is on the front, the front or the back of the parentheses. It works the same way either way. So we do 17 times 2, which is 34, minus 17 times 4, which is 68, n. So we do the 17 times 4, which is 68, and we keep the n, which is in that term. So that's as far as this can go, because those are not like terms, because this is a constant with no variables. This has a variable n, so they're not like terms. We cannot combine them. Excuse me. 34, we have 11 times 4d plus 6. So this is another problem where the distributive property is required. Zoom in a little more. Here we go. So we do 11 times 4d. 11 times 4 is 44, and we keep the d. And then 11 times 6, which is 66. Again, there's no way to combine those because this has a d, this does not, so they are not like terms. Okay, on 35, we're back to combining like terms. 7m plus 2m plus 5p plus 4m. 7m plus 2m plus 5p plus 4m. So we're looking for like terms. Those are the ones with the same variable pattern. And these three have the same variable pattern because they have an m, and it's all m to the first power. So I'll do 7m plus 2m is 9m. 9m plus 4m is 13m. And that is as far as I can go because these two are not like terms, because this one has an m and this one has a p. Okay, 36. Here we're going to see both at once. We'll have to do some distributive property and some combining like terms. We'll see that on this one and on 37. Okay, so the first thing you should do is follow the order of operations. Order of operations says do what's inside the parentheses. But we can't do anything inside these parentheses because they're not like terms. That's a constant, no variable. That has a variable x. No exponents, we can't do that. So multiplying, that's where the distributive property comes in. 7 times 3 is 21. We keep the x. 7 times 4 is 28. So our first step was to do the distributive property. Our next step is to combine like terms. We see two like terms right here. They both have an x, and it's to the first power. 3x plus 21x is 24x. And then this has no like term, it's a constant. So we just leave it as is. And our answer is 24x plus 28. Okay, last one on this page. It'll be similar to the one we just did. 4 times fg plus 3g plus 5g. So again, we cannot combine the what's inside because this has an f and a g. This only has a g. So they have to have not just one variable in common, but all of them. So these two are not like terms because this has both f and g. This has only one g. So I do 4 times fg, which is 4 fg. 4 times 3g. 4 times 3 is 12. And I keep the g. Okay, so I'll just look at the first term. This has no like terms. There's no other term that has both f and g as part of it. So I'll just rewrite that one because it doesn't change. But these two are like terms because they have g to the first power in both of them. 12 plus 5 is 17g. Okay, so that completes our work on page 27. I'm going to skip over to page 66. And from this point, it will go more in order of the way we learned it. You can see if you have the book, this is separated by sections. So starting with 8. It says write a verbal expression for each algebraic expression. So we have h minus 7. Okay, so you always want to talk about the main operation in an expression. The main thing happening here is subtraction. And the word we use for subtraction is difference. So this we could write as the difference of h and 7. So h minus 7, we need to write the word difference because of the subtraction. The difference of h and 7. The difference of h and 7. 9, we have 3x squared. So the main operation here is the multiplying because we don't write a dot, or one's not written, but this is 3 times x squared. So the big word we'd start with is the product. Product is for multiplying. So it's the product of 3. Sorry, I've got the word of. The product of 3 and x squared. So 3x squared is the product of 3 and x squared. Okay, 10. 5 plus 6m cubed. So the main operation here is the addition. Now there is some multiplying happening in this single term, but since we've got two terms, what's connecting those two terms is the addition. And so subtraction is difference, multiplication is product, addition is the sum. So the sum of, and what we're adding together is 5 and 6m squared. So I say the sum of 5 and 6 times, oh, I may have said squared, that's m cubed. M cubed. So again, here's what we started with, 5 plus 6m cubed. So because of the plus, we write the sum, and it's the sum of 5 and 6 times m cubed. Now you could say the product of 6 and m cubed, but to me, the fact we've already used the big word for sum, which is the main operation, that's important to use it for the main operation. But when you're just driving a single term in something with more than one term, you can just use times instead of product. And this example didn't come up, but if there's division, you'd use the word quotient. So subtraction, difference, multiplication, product, addition, sum, and division would be quotient. Okay, now we're switching gears, going the other direction. They're giving us the sentence this time, or the verbal expression. A number increased by 9. So a number increased by 9. Increased by means plus. A number just means a variable. You're welcome to use x or n or any other variable you want. So a number increased by plus 9. Now, some people are tempted to do multiplication when they see increased by, but you've got to remember, increased by always means addition. Okay, 12. 2/3 of a number d, so they tell us what to use as the exponent or the variable this time. 2/3 of a number d to the third power. Okay, so I'll scroll across so you can see. Actually, I'll just back it up. I'll make it easier. Wow. 2/3 of a number d to the third power. So 2/3, we can just write as a fraction, 2/3. Anytime you see of, think multiplication. So we're multiplying 2/3 times d to the third power. So 2/3 times d cubed, or you could just write 2/3 d cubed. Both are equally correct. You can write either one of those. Okay, last one in this section. 5 less than 4 times the number. Okay, this phrase you must remember is the one that makes us do things backwards. In almost all of these problems, you write things in the order they show up. So in almost any other phrase, you would just do 5 first and 4 times the number, 4n second. But you must remember, this phrase is the pesky jerk that's the exception. When you see less than, that communicates you need to subtract. We need to flip the order of these two things. So 4 times the number, we can just write 4n. 5 less than that would be minus 5. So 4n minus 5. So you got to commit to memory. Less than means you flip the order of the things that are written down. Okay, so that covers the things in section 1. And, oh, actually there's one more. I'll just talk through this one. I'm not going to write it all out. 17. I know you can see the answer, but I'll just talk through it and explain. So Fantastic Pins Bowling. Hopefully it'll focus soon. There we go. Fantastic Pins Bowling Alley charges $4.75 for shoe rental, plus $4.25 for each game. Write an expression representing the cost to rent shoes and bowl G games. So when you go bowling, you only have to pay for shoe rental once. Now I'm assuming you're an individual. I understand every person has to pay, but each person just pays for their shoes one time. That's why we don't put any variable with $4.75, because the charge for the shoes is just a one-time flat charge. Doesn't matter if you bowl 1 game or 11 games, you're only going to charge for shoes that one time. But then it's $4.25 for each game. So we're going to have to multiply the number of games we play by 425, because 1 game would just cost us $4.25, but 2 games would cost us double that, which would be $8.50. 3 games would cost us triple that, which would be $12.75. So this requires a variable because this is per game we play. So it depends on the number of games we play, how much we charge for that. So the shoe rental fee is flat and constant. It's the same no matter how many games you play. But the $4.25 does depend on how many games you play. So that's why you multiply it by G. Okay, I'll write that answer here, just so I have it on this paper. And now we're switching gears and focused on the order of operations in this next section. I may refocus in a second, but yeah. Let me just write this problem, then we'll do that. 24 minus 4 times 5. So you've got to remember the order of operations. Please excuse my dear Aunt Sally, PEMDAS. There's no parentheses here. There's no exponents here. So now we look for multiplication or division. We see multiplication right here, 4 times 5. 4 times 5 is 20. Well, now we're just down to one single operation, subtraction. So we say 24 minus 20, which is 4. $19, 15 plus 3 squared minus 6. No parentheses, but there is an exponent, so we do that first. 3 squared is 9. And now there's no multiplication or division, so we're down to addition and subtraction. And you got to remember, we need to do that from left to right. That's true of multiplication and division also, but back on 18 there was only one multiplication to do, so we didn't have to think about that. But here we have an addition and a subtraction. So you've got to remember, we do it from left to right. So I start by saying, what's 15 plus 9? Well, that's 24. Then I say, 24 minus 6 is 18. Okay, 20. 7 plus 2 times 9 minus 3. So order of operations says take care of what's in the parentheses first. So 9 minus 3 is 6. There's no exponents, so we look for multiplication or division. We see multiplication right here. 2 times 6 is 12. Then finally we do addition. 7 plus 12 is 19. Okay, 21. We do 8 times 4 minus 6 times 5. There's no parentheses, there's no exponents, but there is multiplication. So from left to right, we'll deal with multiplication. 8 times 4 is 32. 6 times 5 is 30. So we're down to one operation, subtraction. 32 minus 30 is 2. Okay, 22. 2 to the 5th minus 5 divided by 9 times 11. So we do the innermost parentheses first. So the brackets count as parentheses, but since there's parentheses inside that, we got to look inside here first. And inside here, we got to take care of the exponent before we do anything else. So 2 to the 5th is 32. 32 minus 5 is 27. Because we had to keep going inside those parentheses. So now we just look at these parentheses, the brackets. 27 divided by 9 is 3. And 3 times 11 is 33. $23. 11 plus 4 squared over 5 squared minus 4 squared. Okay, and as I told you, you need to treat the numerator of a fraction as its own parenthesis and the denominator as its own parenthesis. So we want to do everything separately in those two first, then we'll see if there's any division that's possible. So in the top, we'll deal with the exponent. 4 squared is 16. In the bottom, we'll do both exponents. 5 squared is 25. 4 squared is 16. On top, 11 plus 16 is 27. 25 minus 16 is 9. And so now that we've completed all the operations in the numerator and the denominator, we can divide, and 27 divided by 9 is 3. (24) Here we need to plug in values, so it starts with c plus 3a. And given in the instructions, it tells us that c is equal to 9 and a is equal to 4. So I first just wrote c plus 3a, then I plugged in the values it gave me for c and for a. Now I'm following the order of operations. Nothing to do inside the parentheses, it's just a number, 4. No exponents. So we look at multiplication and division. I've got multiplication right there. 3 times 4 is 12. Then we add 9 plus 12 is 21. Okay, 25. 5b squared divided by c. And again, in the instructions, they tell us b is equal to 3 and c is equal to 9. So I got to make sure I follow the order of operations. There's nothing to do inside those parentheses because it's just a number 3. But we do have an exponent. 3 squared is 9. So then we look at multiplication and division. We have both. We have multiplication right here and division right here. Now I'll go and tell you, for this problem in particular, the order doesn't really matter, but there are problems where it makes a world of difference about whether you get the answer right or not by the order you do it. So just always be in the habit of doing it from left to right. 5 times 9 is 45. 45 divided by 9 is 5. Okay, last one, 26. We have a squared plus 2bc divided by 7. All right, got to plug in a, b, and c. A is 4, b is 3, and c is 9. So we got lots to do. We look inside the parentheses first. We do the exponent. 4 squared is 16. Now we've got some multiplying, but I'm going to do it from left to right. So 2 times 3 is 6. Six times 9 is 54. 16 plus 54 is 70. So we got to do that because it's inside the parentheses. And 70 divided by 7 is 10. Okay. Jumping over to number 43, we're switching back to distributive property. If you need more review on the properties, I'd suggest you look back at our notes on that and the worksheet we did. Those would be the best way to review it. So we're back to what we started with, just using the distributive property and combining like terms if needed. We'll see if any of that is required. So on 43, we do distributive property. 3 times x, 3x. 3 times 2 is 6. And no like terms, so we're finished right there. 44, we have m plus 8 times 4. And like I said, we don't treat it any differently whether the number's before the parentheses or after. So I just say 4 times m is 4m. 4 times 8 is 32. (45) 6 times d minus 3. 6 times d, and 6 times 3. Last one, 46. negative 4 times 5 minus 2t. Okay, now notice it's a negative number in front here. So we got to make sure we multiply by negative 4 both times. So negative 4 times 5 is negative 20. And I'm just going to rewrite this minus sign and say negative 4 times 2t, which would be negative 8t. Now technically this answer is correct, but it's best not to leave two negatives next to each other. It's just kind of longer than it needs to be, because as you might recall, anytime we're subtracting a negative, it's the same thing as adding a positive. So negative 20 plus 8t. I don't think I would count off if you leave that answer as minus a negative, but the best way to write the answer is negative 20 plus 8t.